Today's session on economics is talking about economics in economics. How about that? So before we kick off, sort of acknowledge the traditional owners of the land on which we meet and the land about which we're going to talk about, and pay my respects to elders past, present and emerging. This session today should be reasonably brief, I hope, but let's see. So I'll play the video. Sorry, we'll record this video of the presentation and then turn the video off and have a little discussion about these different topics. So just a quick reminder, so economics platform, there's 4 key components: economics plan, high level investment planning, economics project, project level or farm level modelling, impact reporting and facilitation for economics markets. So we're talking about this high level investment planning, economics plan, and economics plan. So it's a subcatchment lumped modelling approach, and it's all about rapid investment portfolio generation. And the audience here are investors, so investors in NRM, and the users of the tool are those investors, NRM bodies and local government authorities, so the administrators of sort of broader NRM programs. And so the approach here is trying to have consistent approaches across large spatial areas, so that we've got consistent approaches for coming up with portfolios of actions. And that's distinct from the economics project farm level thing. We can have very locally specific information and approaches. And economics plan, if you're familiar with reefonomics, that's been developed for the Great Barrier Reef region. We're largely following that model here. And that's what we're pitching for the economics component of economics plan. So when it comes to coming up with portfolio generation, so one of the principal ways to prioritise that portfolio of potential actions is a cost per benefit. So if we think about a water quality, it's the simplest way to imagine this, I guess. It's $1 per tonne of fine sediment reduction, or $1 per kilogram of nitrogen reduction. So how do we come up with those dollars? So each of the actions that we have represented, and there's about 150 different actions we've got together so far for economics. So these are all the on-ground things you might do, plant trees or change agricultural management practice. We've got to represent the cost of implementing those actions. And this is fundamentally what would the cost be to the donor organisation or the investor to make those changes happen. And what we've got in reefonomics is effectively just a single CapEx or capital cost and operating cost, basically, for those actions. And what they capture, and we anticipate doing exactly the same thing here. So what they capture is effectively the direct grant cost. So, and this is typically captured as unit cost for sub-action elements, if you like. So we've got an action of fencing a stream and replanting it. We'll have a unit cost for fencing per kilometre and revegetation per hectare. Combine that up and we effectively get a cost for the action. And then we've got a grant administration cost. So it's typically a program level cost, and we'll proportion that up to give kind of an equivalent cost per action. And then there's the cost of kind of extension or regulation or enforcement associated with the action. And at the moment in reefonomics, you bundle those all up and say, here's the combination of those things, the capital component and the operational component. What we're proposing in economics is to more explicitly represent those as sub-elements, so you can see what the components of those are. And that could form the basis of an action. Is one action doing the same on-ground work might have a larger grant component, or it might have a larger extension component, and to put that into the mix of potential portfolio items. What could also be included is the cost to the landholder. But I propose that we don't do that in the plan level tool. This is definitely at the project level tool. Here's a screenshot from the paddock to reef projector tool, which is a project level tool. We do exactly that. So there's an opportunity to capture the cash and in-kind contribution and the land collar. So the donor organisation, the cash and the time cost, and the cash and the time cost from the landholder as well. And so that's our approach about capturing the dollars. Now, there's a discussion we need to have about discounting. So fundamentally, discounting is used to convert a future value into a current value. And the basic premise of using discounting is to be able to trade off alternative investment strategies using a common kind of present value dollar figure. Reefonomics, we've got no discounting implemented in there. And the rationale for no discounting, firstly, there's no investment trade-off necessarily. There's committed funds, and the tool sorts the investment options for that budget. So that typically those committed funds don't have a concept of discounting in them. So it's a fixed amount of money on the table, and whether you spend it this week or next week makes no difference. Secondly, discount rates are confusing if you're not an economist. So we go, okay, if it's not absolutely critical and it's not going to change the order of actions that you might do, don't put it in there. Even the concept of OPEX, so being able to budget for future operational or maintenance costs of things, typically doesn't occur in the NRM funding sphere. And then if the third element here, if you discount rates, they simply add another variable to the computation, and effectively we want to try to keep things as simple as possible. So every other variable creates another way to be wrong. So unless it's absolutely critical, it doesn't need to be in there. So that was our thinking 18 months ago when we were developing the Reefonomics approach. Implementing discounting is a computationally trivial thing to do. And we're sort of leaving that door open, I guess, in the economics world as to whether to implement or not. So I'd be keen on your feedback around that after the presentation. And then there's a third component here. Bear with me while I get there. So the basic computational approach in economics plan is to have an area available to do work on, and available area to length of stream that we might do riparian work, and then the condition of the things that we care about might be a water quality measures or a biodiversity measure. We've got an action which might be to revegetate, and that action has consequences on the conditions. We apply the action, we do some accounting, change the available area, update the condition. But the point I wanted to get to is each of these elements has got a confidence around it. So we've got the confidence in the underlying condition. We've got a confidence in our ability to predict an impact on that condition, and they propagate through to give us overall confidence in our predicted change in the measure or value. I'd really like to have the same, be able to do something similar, if you like, for our estimates of how much it's going to cost to do work. So those donor costs. So some things we've done a lot of, and we've got a great record and know with a high level of precision how much it's going to cost. And some actions are pretty new and novel, and so the potential range of costs is large. So to be able to communicate that or propagate that through to the end interface to be able to, or even to use as a basis for filtering the type of actions that you might choose. So only choose actions that we've got a high confidence about the cost, or be able to communicate the relative potential ranging costs based on the portfolio you choose. And this is how we represent confidence for the values component in here. So what's our confidence in our predicted water quality outcome? And this is precisely the approach for representing data confidence in Great Barrier Reef reporting. So it's a thing and it works, and why invent a new thing? So it's got a currency. So we propose to use that for representing the confidence in let's say our water quality prediction and our changes in values, and also representing the confidence in the underlying data that drives it. And I would like to apply the same approach to represent our confidence in the financial prediction. Now, there's other ways we could do the error in the financial prediction. Why I like this way is it just means there's a consistent representation of confidence throughout the application, so not have to learn two different ways to get there. I'll be keen on your feedback on that. So that's the end of my key points that I was keen to get feedback on. So that's the end of session 9. Environmental accounting on Monday. This is principally about potential investors in NRM and what they would like to see in terms to give them confidence that their investment is going to be worthwhile. So the level of quality of prediction and the types of measures that they want to see. So I'll post this video where the other videos are on economics.net.au. Thanks very much.